Hello, in this video we will be discussing functions and function notation. So these notes correspond to a free college algebra textbook from OpenStax. It corresponds to section 3.1. So in this section we have a few things that we need to define. So let's start with some definitions. So a relation is a set of ordered pairs. It's really just a relationship between two items, two expressions, two variables. It's just a relationship. The domain is the set consisting of the first components of each ordered pair. It's sometimes called the input. It's given by the letter X. The range is the second component of the ordered pair. It's sometimes called the output, and it's usually labeled with a Y. A function is a special kind of relation in which each possible input value leads to exactly one output value. In other words, the X value cannot repeat. So if you have the same X value used more than once and it goes to a different Y value, then that is not a function. A function is one-to-one if each output value corresponds to exactly one input value. So in other words, you can't have repeated X or Y value. You can't have a repeated X value because then it's not a function. And in order for it to be one-to-one, no Y value can repeat. So let's look at some examples just to determine if something is a function or not. And we'll also be asked to state the range in these first few. So, number one, determine whether the relation represents a function, then state the domain and range. So if we want to know if it's a function, we're looking for whether or not the X values repeat. So in this example, we have 1, 3, 1. So if you haven't noticed yet, hopefully you have, you can see that the 1's repeat here. Those are both X values. So because a 1 is used twice and they have different Y values, this is not a function. Okay, we can still give the domain and range, but just know that it's not a function. So then a follow-up question, which is not asked here, but let's say I asked you, is this a one-to-one function? You would say, not a one-to-one function. You don't even have to check, because if it's not a function, it can't be a one-to-one function. Okay? The Y values do not repeat, but the fact that it is not a function means it cannot be a one-to-one function. So that's the first step, is checking to see if it's a function. The domain is 1, 3, and then 1 again. So the domain is all the things that I've highlighted in green. The domain is the set of X values. Your range is going to be your set of Y values. So what I'm highlighting in blue is going to be your range. So your range includes 2, 4, and 3. You do not have to put these in numerical order, but you could if you would like. So you could put 2, 3, 4. Notice that in the domain I only put 1, 3. I did not put another 1. So when you're listing the items in the domain or in the set of the range, you only list each item once. It doesn't matter how many times it appears, you only list it once. So let's look at number 2. Number 2, again I have a set of ordered pairs. There are 4 ordered pairs. Let's go ahead and highlight the domain in green. So we're going to check to see if it's a function. 1, 2, 3, 6. So none of those values repeat. So if I want, I can go ahead and write the domain. 1, 2, 3, 6. Those are all different. So that means it is a function. Alright, so since it is a function, I could check to see if it's a one-to-one function. So let's go ahead and do that. I'm going to look at the Y values now. 5, 6, 5, 5. Okay, clearly 5 is used more than once. That means it's not a one-to-one function. Okay, so it's not one-to-one because the y values repeat. And so the range is 5 and 6, and that's it. Okay, so again, it is a function because no x values repeat. It is not one-to-one because the y values repeat. Let's look at number 3. So number 3, we're looking at the domain. The domain is the set of x values. So here's your domain. We have 5, 10, 15. So your domain is 5, 10, 15. Okay, and then we're going to look at our y values for the range. The y values are 3 and 8. Oops. And we can see that the 8 has been used twice. No x values repeat, so it is a function. But since the y values repeat, it is not one-to-one. So even though it didn't ask us specifically for the one-to-one information, it's good practice. So we're just going to go ahead and look at it as we go through. And number 4, same directions. So I've got the x values, that's my domain. The y values, that's my range. So for the domain, I have 11, and that's it. So my domain is 11, and my range is 3, 4, 5. Okay, so is it a function? It's not a function because the x value is used more than once. It can't be a one-to-one function because it's not a function. So in order for it to be one-to-one, it also has to be a function. Okay, so next we're going to talk about function notation. So in those 4 examples, we saw examples of relations, some of which were functions, some of which were not, given an ordered pair form. So they had a set of ordered pairs like number 1 and 2. And number 3 and 4, it was given in a chart, but it was really just another way to represent ordered pairs. But sometimes you might not have a set of ordered pairs, you might have a relationship given as an equation. So that's what you want to look at here. Function notation is simply replacing the y value with f of x when you solve for y. So in this first example, this is the same thing as y equals 2x minus 5. So it's the same thing as a linear equation, y equals mx plus b, right? It's in that form. But they just replace the y with the f of x. And this is to indicate that it is a function. So if it's in function notation, if it's written with an f of x or a g of x, that means it is a function. So if I ask you, is this a function? You can automatically say yes because it's written in function notation. Now, keep in mind that f of x does not mean f times x. This does not indicate a multiplication. All this is a notation to tell you this is a function and the variable is x. So you could replace this with anything. Another example, you could write g of m is equal to m plus 2. That means this is a function. We're calling the function g. And the variable you're going to see is m, which is what you can see over here on the right. So the left-hand side over here is telling you that this is the function's name, and this is the variable that you're going to see on the other side of the equal sign within the function. So it doesn't have to be an f. F is kind of the generic because function starts with f, but it could be any letter you want. Okay, so that being said, let's look at number 5. The good thing about having it in function notation is that you can easily evaluate for different numbers by plugging in the number for the variable. So for example, if we want to know what f of 1 is, notice the 1 is taking the place of the x, right? It's taking the place of the variable. So what we want to do is have it take the place of the variable everywhere. So on the other side of the equation, we have 2x minus 5. I'm going to replace the x with a 1. Then you can just simplify. So this is 2 minus 5, which is negative 3. So your answer is negative 3. So if you want to evaluate for f of x at f of 1, the answer is negative 3. It does not ask for this here, but be aware that this corresponds to an ordered pair. So this value, 1 replaced what variable? 1 replaced the x variable. So that's the x value. Remember that f of x is equal to y. So when you're solving, you're finding the f of x value. So that's the y value. You could write this as an ordered pair if you wanted to, or if you were asked to. So the x value would be 1 and the y value would be negative 3. So understand that this is corresponding to a set of ordered pairs. You can get a specific ordered pair by evaluating at a specific x value. So you can write it just as negative 3 if it's just saying evaluate, or if it says write your answer as an ordered pair, you could write it like that. Okay, so let's look at part B. So part B, A is taking the place of the variable. So everywhere I see an X, I'm going to replace it with an A. You should be in the habit of, when you substitute something in, put parentheses around it, and then as you evaluate it, you get rid of the parentheses. So in this case, the parentheses really aren't needed. 2 times A is just 2A. And since those are not like terms, there's nothing else I can do. So that's it. That's my final answer. If I evaluate at A, I get 2A minus 5. So notice if you plug in a variable, you are probably going to get an expression out. If you plug in a number, like in part A, you're going to get a number. Okay. That's usually the case. Part C, solve f of x equals 9. So notice this is different. The other two, we had replaced the x value with a number or a variable. Now we're saying f of x equals 9. That means the entire thing equals 9. So look at our equation. Our original equation is f of x equals 2x minus 5. So now we're going to replace the f of x with 9. So this is different. This is 9 equals 2x minus 5. So in the other cases, we are substituting in the variable or the number for x. Here we are setting the expression equal to the value given. So now we're just going to solve. So we'll do plus 5 on both sides. And we get 14 equals 2x. Divide by 2. And we get x equals 7. So this time we were given the y value and we were asked to find the x value. So kind of the opposite or inverse of A and B. All right, let's look at the next one, number 6. We have the same directions. So we want to just evaluate or solve for the information given. So for part A, we're finding g of negative 2. So I'm going to plug in negative 2 everywhere I see an x. And remember, you're putting parentheses around it. This becomes more important when you're plugging in numbers, particularly negative numbers. So you'd be really careful here. Now make sure you remember the order of operations. So you need to make sure you apply that in the correct order. So you need to do the exponents first, right? Parentheses, then exponents, multiplication and division, and then addition and subtraction. So exponents first. So we're going to just bring down the negative 5. Negative 2 squared is positive 4. Negative 2 times negative 2 is positive 4. Okay. Now I'm going to go through and do the multiplication from left to right. So negative 5 times 4 is negative 20. Negative 10 times negative 2 is positive 20. Negative 20 plus 20 is 0. So your solution is 0. Okay, that's the y value. When x is negative 2, y is 0. Okay, now we're going to do part B. Part B, I see a negative y, so I'm going to replace every x with a negative y. So we have negative y squared. Remember, you do the exponents first. A negative times a negative is a positive, so I'm going to bring down the negative 5, and then this is going to be positive y squared, so that's going to end up being negative 5y squared. And then negative 10 times a negative y is going to be plus 10y. Now, those are not like terms, so there's nothing else I can do here. I'm just going to leave it like that. And finally, 6c, we're going to set it equal to 0. So we're going to have negative 5x squared minus 10x is equal to 0. So this is a quadratic equation. I need to solve by factoring or quadratic formula, complete the square, some form like that, right? So here I'm going to factor because I can factor out a greatest common factor. So I can factor out a negative, a 5, and an x. So if I divide out a negative 5x, I am going to get x plus 2. So the negative 5's cancel in the first one, right? X squared over x is just x. The two negatives make a positive in the second one. 10 divided by 5 is 2, and the x's cancel. Alright, so now I'm going to set each factor equal to 0 and solve. So negative 5x equals 0. When I solve that, I'm going to divide by negative 5, and I get x equals 0. So one solution is 0. And then I'm going to set x plus 2 equals to 0. Subtract 2 from both sides, and I get x equals negative 2. So my two solutions here are 0 and negative 2. Okay. Number 7, same directions. We want to evaluate or solve given the information. So h of 0, I'm going to plug in 0 everywhere I see an x. So we have 6 times 0 minus 1 over 2 times 0 plus 4. Okay, so 6 times 0, that's 0. So that's just going to be negative 1. 2 times 0 is 0, so that's going to be 4. So negative 1/4 is my answer there. Okay, so no problem, we can plug in 0. So now we want to plug in negative 2. So 6 times negative 2 minus 1 over 2 times negative 2 plus 4. So again, we're plugging negative 2 in everywhere there was an x in the original. So this is going to be negative 12 minus 1 over negative 4 plus 4, which is going to be negative 13 over 0. Okay, so remember that if you're dividing by 0, that is undefined. So if a 0 appears on the bottom, remember that's undefined. So that's it. You've got to keep an eye out for that. There's no solution here. It's an undefined value. So remember, the bottom or denominator of a fraction cannot be 0. Okay, so for number 8 through 11, we're going to use the table given. So this is another way you can evaluate for a function. So we can see that this is a function just if we look at the given x values. There are no repeated x's. So we're going to evaluate for the given information below. So if you have a table, what you're going to do is you're going to look for the value in the correct column or row, depending on how they have it set up in the table. So for this first one, number 8, the 5 is in the place of the x. So we're going to go to the x column and look down until we find a 5. And when we do, we're going to look over and see what the associated y value is. The associated y value is 16. So that would be the answer here, 16. Okay, simple enough. So we're just looking for the correct information in the chart. Okay, let's look at the next one. So for the next one, we have a 0 in the place of the x value. So we're going to go to the x value column and we're going to find 0 under the x value column. And we're going to look over and see the associated y value or the associated f of x value. And we see that that is 32. So that will be what we're looking for here. So the answer to number 9 is 32. Okay, so now let's look at the next one. The next one, solve f of x equals 0. Okay, so notice now we have the 0 here. This is the f of x value. This is not the x value, it's the other value, the y value, or the f of x value. So we need to go to the f of x column and look down until we find a 0 in that column. Then we're going to look at the associated x value, and we see that that's a 3. So the answer to number 10 is 3. So for the y value of 0, we have an x value of 3. So remember, this is like the backwards of 8 and 9. All right, so finally we're going to do number 11. So for number 11, we have solve f of x equals 16. So again, 16 is the y value or the f of x value. So we're going to look at the f of x column and go down until we find the 16. And we're trying to find the associated x value. And we can see from our chart that that is 5. So the answer to number 11 is 5. So these really are not difficult if you know how to do them. You just have to make sure you're looking in the appropriate column and matching it with the number across, right? Okay, so the next thing is we could have our function given to us in graph form. So instead of a set of ordered pairs or a table or a function, an equation, we could have a graph. So we have a couple of tests to determine if something is a function or if it's one-to-one. The first one is the vertical line test. So the vertical line test, remember a vertical line is, let me move this down a little bit so I have some space to write. A vertical line is up and down like that, right? And on a vertical line, remember that the x values repeat. So this could be -1, 2, and this could be -1, 4. The x values are the same on a vertical line test. Remember, the x values cannot be the same in a function. So if you can draw a vertical line anywhere through your graph and it passes through more than once, it's not a function. Likewise, the horizontal line test, so a horizontal line looks like that. This is going to have the same y value. So for example, let's say this is our coordinate grid and our black line is the line we're looking at. This could be -1, -1, and 2, not -1. It could be -1, 1. That would make more sense because it's above the red line. And then this could be 2, 1. 1, 2, 1, -1, 1. Okay. Notice that the y values are the same. If it's 1 to 1, the y values cannot be the same. So if you draw a horizontal line anywhere through your graph and it passes through more than once, it's not 1 to 1. So let's use that information for these. So for number 12, we want to know, is it a function? Is it 1 to 1? And then we want to do some evaluation with the graph. So is this a function? So I'm going to try to show it's a function with, with green. So let me get green. Okay, so is it a function? I'm going to try to draw a vertical line. Anywhere I draw a vertical line, it only passes through once. And it doesn't matter where I draw it, it's only going to pass through at one point. So yes, this is a function. Okay, so now I want to decide, well, is it 1 to 1? So to decide if it's 1 to 1, I draw horizontal lines. Okay, so let's look at blue. Is this a function? Okay, that line, it passes through the graph 4 times. So no, this is not a 1 to 1 function. It is a function, but it's not 1 to 1. So it passes the vertical line test, but it fails the horizontal line test. Okay, and now I want to evaluate for f of 0. Here, 0 is the x value. This is the x value. So I need to find 0x. So here's 0x. Now I want to know the associated y value. Well, in order to find the associated y value, I have to go to this point. That's on the graph. This point is 0, 1. The x value is 0, which is what I want, and the y value is 1. So the answer would be 1. Okay, part D is the opposite idea. Part D is we have the y value of -3 and we want to know the x values. So they're giving us the y value. So here is the y value of -3. So now we want to find the associated x values. So here's 1 and here's 1. So the associated x values are -2 and 2. There's actually 2. So -2 and 2 are the two associated x values with the y value of -3. Do not use parentheses. These are not, it's not an ordered pair. These are the two separate x values associated with that y value. So you can put them in curly brackets if you want. Okay. Number 13. So we're going to start with, is this a function? So if it's a function, it has to pass the vertical line test. If I draw a vertical line here, I can see that it passes through more than once. So this is not a function. No. Is it a 1 to 1 function? Well, it has to be a function here in order to be a 1 to 1 function. So you don't even have to do anything. If it's not a function, it's not a 1 to 1 function. So done. Okay, now I know it doesn't ask us for it here, but let's practice finding function values. Let's just say it asked us to evaluate, so let's make a part C, evaluate f of 2. Okay, so this is an x value, right? So this is an x value. So when x is 2, here's the 2 on the x-axis, right? So when x is 2, let's see what y values we get. Here's 1, and here's 1. It looks like a little less than 1, right? So I guess that's why they don't ask you for function values, because they're not even numbers. Let's just say 2/3 and -2/3. So the x value 2 is associated with two different y values. That's why it's not a function. Okay. So number 14. Is this a function? So can I draw a vertical line through and it pass through more than once? No. No matter where I draw a vertical line through this graph, each vertical line is only going to pass through exactly one time. So this is a function. It passes the vertical line test. Then I want to know, okay, well, is it a one-to-one function? So does it pass the horizontal line test? Anywhere I draw a horizontal line through this graph, each horizontal line is only going to pass through exactly one time. So yes, it is also a one-to-one function. So any linear function, any line is a function unless it's a vertical line. So if it's a vertical line, it's not a function. And if it's a horizontal line, then it's not a one-to-one function. Okay, so let's see. This one I can ask some evaluate questions and they will make, well, it'll be easier to see, I guess, because we have them lined up nicely. So let's say evaluate f of 1. Okay. So when x is 1, so here's our x value, what's the y value? When x is 1, y, I'm right on the line, y is 0, because the ordered pair here is 1, 0. What about part D? Solve when f of x equals 0. Nope, not 0. When f of x equals -2. So in this case, this is our y value. So y value is -2. Here it is. The x value is 0. So this ordered pair is 0, -2. So your answer here is 0. Alright, so this is just kind of an introduction to functions and function notation. The last thing I'm going to put here, and I want you to look at this in your textbook, are the toolkit functions. These functions you should have memorized. It's going to be very important that you know these basic functions. You know the name. So you know the name. You know the equation. You know the graph. And you know some points or ordered pairs for these. So, for example, the first one you should know is a constant function. It's when f of x equals a constant number c, okay? You get this line, and you get the points on the right. So these are just some points. You don't have to have those specific points memorized. You can if you want, or you can pick other points. But you should know some of the basic, you should know at least 3 points so you can get the basic shape of each graph. So the second one is the identity function. It's going to be a line. It's y equals x. Remember, for all of these, this is like y equals, right? The f of x means y. So you can memorize it either way. The next one is the absolute value function. So we talked about some equations with absolute values at the end of chapter 2. The graph looks like this. It's a V. We have quadratic function. That is going to be a parabola, which looks like this graph. We have a cubic. We have the reciprocal function, which we haven't talked a lot about yet, but you should know what the graph looks like, so memorize some of these points. The reciprocal squared function, so this is 1 over x squared. The square root function, and the cube root function. So you should have all of these, I believe it was 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, all 9 of these memorized. The reason is, in a future section, we're going to be transforming these, and if you don't know the basic shape and what they look like, you're not going to be able to do the correct reflections and transformations. It's going to take you a lot longer. You do not want to have to try to make ordered pairs for all of these when you're doing these. You want to have them memorized so you can quickly draw a sketch and make the appropriate transformations. So make sure you look over these and memorize all of this information prior to any quizzes or tests, definitely prior to the midterm.